Last time you got to see the new test cuts with the new mill spindle. This time we're going to make a real part with it. Welcome back to Cloud 42, I'm James. Well, this video is a part of my series on putting a new spindle on my Grizzly G0704 mill back here. I think we're through most of the yak shaving. The spindle is running, it's time to make parts. Today, I think we're going to start by making a bracket so that I can mount the remote VFD operator actually on the spindle instead of where it is right now, which is over here tucked under the handle of my toolbox. Now you've of course seen this model before. This is the new 3 horsepower spindle for the Grizzly mill and the mount that I machined to mount it onto the Z slide. And you'll remember that I put some holes in the side here. In addition to the holes for the tramming bars, I just put 4 1032 holes in each side of the mount. And I said that was for attaching things. And today we're going to make one of the things that attaches there. Now the bottom screws I intend for attaching coolant mister attachments, because this isn't steel, so we can't use a magnet, it's aluminum. But the top two I want to use to mount the operator for the VFD. So I've got that modeled. It's not yellow, but I've got it yellow here so it's easy to see. And this is about where I want it to sit. I want it to be on the front of the spindle where I can see it clearly. I could, display the spindle load, or I have the start and stop buttons. I'll have the knob to control the speed if I'm doing it manually. And so this is about where I want it. And I want it kind of high enough up that the logo that's on the front here is still visible and, not completely planted in the front. And then it's got a connector here for where the cable's going to come out to connect to the VFD. And I want to make sure that that's clear and there's plenty of space for that to come out to the side and then go up. And so what I want to do is make a sheet metal bracket. And I've got that modeled in here. And it's not going to be red, it's going to be aluminum. But again, I've got this so that you can see it easily. So it's going to attach to the 2 screws here on the side, come forward, and then it's going to attach with a couple of M3 screws to the pre-existing holes in the back of the operator so that it can be mounted there. And down here, these are 1032s. So I modeled this up in Fusion as a sheet metal part. I'm not going to go into the details of that right now. If that's something you'd really like to see, is how to model sheet metal parts in Fusion, let me know in the comments and I can take a look at that. But when you model this, as a flange and then you add on, here's a flange that comes outward at 10 degrees, and that's because there's a little bit of misalignment. The spindle is slightly wider than the back plate, so there's a little step there. So I put a little jog, came out 10 degrees, then bent back 10 degrees, came forward, and then bent 90 degrees. So in Fusion, you can just model it that way as a sheet metal part. And then you can come up here to your flat pattern, and you can activate it, and you can look at a flat pattern of the part. And it has a rule for the material that you're using that has information about the bend, radius, and the way the material flows when you form it. And so it can then figure out what size the part needs to be and where the fold lines are so that you'll get the outcome that you actually modeled. And sometimes you have to tune that, but in general, for stuff like this that's not real fit critical, the defaults are just fine. And this is a 1/8 inch thick material, and we're just going to mill this out of a piece of sheet aluminum and then bend it. And as long as we're going to have this thing flat down in the mill so that we can mill around it, we might as well throw a sketch on here and engrave a logo on the side. And this probably exceeds what you would consider a maker's mark or a touch mark, but this should be fun. We can try out the high-speed engraving and see how that goes with the new spindle as well. So I think we just need to go out to the mill, slap a piece of sheet metal on it, and give it a try. Nothing left to do but to do it. This is the material we're going to use for the bracket. This is 1/8 inch thick 5052 aluminum. Now, normally on, when I'm doing milling projects, I'm normally using 6061, which is actually what this block here in my vise is. But for the bracket, I'm going to use 5052, and the reason is because I need to be able to bend it. And 6061, especially in this kind of thickness, especially in a T6 temper. When you bend it, it tends to crack, tends to break. 5052 actually bends a lot easier, so that's what we're going to use. Now the downside of 5052 is that it tends to be very gummy when machining, and I've actually run into a bunch of trouble trying to make brackets out of this material. This is a bracket that I made that you may have seen on Instagram. I uploaded some photos of this when I made it. This is for mounting a fog buster on this machine ultimately. And this was made using the same process I'm going to show here today, milling this out. But this 5052 is really gummy. Even using my favorite YG1 aluminum end mills, going through this, I had to take this in 4 depths of cut, because if I went deeper than that, it would just gum up and chip weld onto the cutter. So we're going to take this nice and easy. Of course, we have a much higher speed spindle, so it'll take less time to take this in multiple depths. But honestly, I have no idea if the higher speed is going to make the gumming and chip welding worse or better. It's also coated end mill now from Lakeshore Carbide, so we'll see how that goes. But to hang on to this, I'm going to use super glue. There's not really a good way to clamp this, since I have to slot out around the bracket, and I could try to grip it with the Talon jaws, but again, as I slot this out, in this case I'm going to cut completely through the part, so there will be nothing left to grip unless I leave tabs. But if I've got vice pressure on it, I'm going to need some really big tabs to make that work, so I think the super glue is the best way to go here. So I'll lay down blue painter's tape here, blue painter's tape on the part, and then super glue the two together. This is something that John Saunders showed over on NYC CNC a long time ago, and I've used it a handful of times and it works really well. Of course, you have to be able to peel your tape. Make sure this is burnished down good and tight. And then we will stick this down with super glue right about the back edge of the vise, just to try to make sure that we keep the part within the work envelope of this mill. Now I'm using Loctite 414 just because, well, because it's worked well for me in the past, and because it's a little bit thicker than some of the other formulations that I use for other jobs like 420. That should be the biggest of plenty. Never really had a problem with not getting enough. I always have too much is my problem. And clamp that with a 246 block. And I've actually got a couple of woodchuck clamps here just to make sure this is nice and secure. Okay, and we'll let that sit for a few minutes and make sure that the super glue has grabbed. Okay, this is, the glue has set and this is nice and solid. So we've got the aluminum plate with a tape on the back, layer of super glue, layer of tape on an aluminum platen. So this should be ready for milling. We just need to locate the top corner here. And let me grab the Heimer for that. And let's locate that corner. And then just as a sanity check, I'm going to take this thing to 0 with the MDI just to make sure everything's good. So G0, X0, Y0, Z0. And that looks just about right for tool 99. Okay, first up, tool number 2, carbide spotting drill running at 6,000 RPM. Let me get the coolant set up here. Okay, the second tool is number 29 drill, running at 9,000 RPM. Next is an 1/8 inch end mill to bore out these holes. And that looks perfect. I can see the drill point that went through the tape to the substrate, but around the sides I still see the blue tape. So we didn't go completely through the blue tape when we milled, which is what I planned. I went 1/1000th of an inch below the bottom of the part, which should be in the layers of tape and glue. I'm just checking everything, double checking it against my setup sheets, making sure everything looks right. Don't want to crash this thing badly on its inaugural run. And since everything's moving faster than it used to, I'm just trying to be as careful as I can. Okay, the next tool is tool 15. It's a 3-flute 1/4 inch end mill. We're going to use that to contour out the sides. This is the main event. Okay, I got a little bit scared there because as we got deep in the hole, I was hearing something. I think it was chip recutting. It might have been a little bit of chatter. I'm not really sure. Slotting is always tricky, and it's tricky especially in 5052. And there's lots of blue tape ground up and ground into the side there. I think the coated end mill picked up a lot more of the blue tape than the polished end mill did when I did this previously. Yeah, you can see there's quite a bit of tape and super glue residue on the cutter. It does come off just with the fingernail, so maybe that's just cosmetic. I'll take a look at this later under a microscope and make sure we're good. Still shaking a little bit. The first cuts on a new machine, especially with unfamiliar process. Like, I'm used to the way this thing works, right? Switch on the coolant, switch on the spindle, and having this thing just be so silent and the coolant not be on, it feels like I'm missing something. So I've got years of experience and it's all different now. But so far, so good. Okay, the last tool here is tool 31. This is a carbide engraver from Lakeshore Carbide, 20-degree angle per side with a 20 thousandths ball. And we're just going to engrave 5 thou deep and try to put a logo on this thing, see how that turns out. Keep trying to turn on the coolant. Well, the engraving's definitely there. It definitely raised a burr. I'll have to brush or sand that down. Shouldn't be a big deal. And then let's take out the part. And for that, I've got another woodchuck tool here. Pop this off, just to get it out of the way. There it is. I was trying to figure out if I got a bunch of chatter on the side. And it looks like not really. It looks like it's mostly just tape and super glue. It's just gummy, and then once it's off, it looks pretty clean. Okay, let me clean this up a little bit, and let's go bend it. Now I've got the diagram here showing where the bend lines need to be, and I need to mark those on the part. So let's start with this one. We need to go 902 from the end. Let's see, 8, 9. I need more range than that. Come on. And that's going to be bent over, so it needs to go on this side. Okay, so there's that line. Then the second line down here will also be on the back, 1.178. Okay, and then the last one is on the front at 0.693. Okay, there are the marks. That's a slight jog out, slight jog back in, and then a 90-degree bend up at the other end. And see how the engraving turned out. Once I hit this, I just hit this with some red Scotch-Brite, just by hand, just buffed it up along the length of the part, gives it kind of a brushed look, and it cleaned up that engraving beautifully. Very happy with that. Okay, let me get set up to do the bending. Okay, to do the bending, I'm going to actually do it right here in my Wilton vise. This is a 6.5-inch model. And I have a set of bending jaws, bending brake jaws for the vise. And these are just magnetic, and they attach. I'll put a link to these down in the description. This is the 6-inch version. They make all different sizes for all different vices. And then this is the tool. And it's actually a very, very sharp tool, creates very sharp bends. So I'll drop that in. And then all we have to do to make a bend, let's start with the 90-degree one, is just line up the score line that I made with this jaw. And in fact, you can kind of feel it. So it's easy to line up. And then just close the vise to make the bend. Now I'm not sure exactly how this is going to behave because of the angle here. It looks like I did keep my logo back far enough it's not going to get marred. And just give it a squeeze. I don't want to overbend it. I'm going to risk underbending it slightly. Check it with a 1, 2, 3 block, and we're a little bit short of 90 still. And now we're past 90. That, fortunately, is very easy to fix. All you need is a little piece of shim and a hammer. And you can open it up just a touch. We're still just a little bit past 90. And that is just about right on. So there we have one end bent. Now we need to put a little jog in the other end. And I think I'm going to start here. I have enough meat, I do. Let's just give that a little tweak. It's only supposed to be about 10 degrees. Yeah, that looks pretty good. Clear the bend? Not really. Let's just give it a little tweak and see where we get. That doesn't look too bad. Actually, I'm going to say that's just about right. So that is the bending complete. And you can see it does mar up a little bit. We've got some marks. Now I'll have to say the first bracket that I bent using these jaws bent a lot harder, just took a ton more force. This one actually went pretty easily, and part of that is because I actually modified this vise, and if you check out my Instagram you can see photos of the modification, but I actually put a roller bearing in here, a thrust bearing, roller thrust bearing that actually makes it take very, very little force to drive this in. So for metal bending it's great. As a modification for the vise in general, the jury's still out because not only does it make it much easier to clamp, it also makes it much easier to release. Even when you've got something clamped down nice and tight, which takes very little force, you can just bump the handle and it'll release. So jury's still out. So far I've been enjoying it, but in the long run, we'll see if I really enjoy having the bearing in there. Well, let's take this over to the mill and mount the controller. That was the whole point of this exercise. Okay, we got the bracket, and I've got the remote operator here for the VFD, and this just mounts right on the front with a couple of M3 screws. I made these holes just a little bit big, so they're like 4 millimeters, maybe 4.2, I don't remember exactly. So I'd have a little bit of adjustability, though I don't believe that's going to be needed. And then this whole thing just needs to go up here on the side of the mill. Let me take out the set screws I had in here just as plugs to keep trash out of the threads. And I've got some 1032 screws with washers, and these holes should actually be quite tight because I intended for these to register closely, and I knew that since I used the CNC for all these holes, they would line up for sure. Oh yeah. Oh, and that is beautiful. I mean, there's a little bit of flex, which is what you would expect with a piece of sheet metal like that. And ultimately, I won't be running it based on this very much, but maybe a little bit longer bracket would have been a little bit better, just to give it more support, because some of that flex is plastic. Anyway, I think that will work. Let me grab the cable. And I'm most certainly going to bang the cameras around here. Okay. Which way is the connector? That way. And we have an error, and the error is because the VFD tripped because it lost contact with the control panel. So I can reset that. We have control of the speed, and we can run. And stop. Beautiful. That's really nice. And I screwed up. I put it in the bottom holes. The bottom holes are for coolant. I wanted it in the top holes because I also wanted to keep the logo here clear. Okay, one moment while I fix the obvious thing I did wrong. And also while I murder that fly. And there we go. Nice and high up. It's high enough it's going to be out of any of the mayhem down here on the table. I've got my speed control, though ultimately I'm not going to need this. I can do all the programming, anything I need to do from here. And that is beautiful. Need to zip tie the cables up, and you can see I got a green cable for this, which matches my green line, air lines, and my green spindle cable. So I think aesthetically this is going to work as well. Well, that is the first part from this new spindle, and I have to say this thing moves so fast compared to what I'm used to that it is a little bit terrifying, because I'm just constantly aware. I've run into problems with CNC before where, you know, I start getting chip welding and then bam, the cutter breaks. And this, with this spindle, that is going to happen well, about 6 times faster. So I'm still a little bit apprehensive. We'll get some experience with it, and I'm sure I will start to feel more comfortable with it. Till then, if you're enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.